Okay, evening everybody. This is my go at topic 4, key assessment 2. So our first one says textiles are used to textiles are often made from plant fibres. The use of plant fibres is more sustainable than the use of synthetic fibres made from fossil fuels. Okay, give reasons why the use of fibres from plants is sustainable. So from plant is important here and sustainable is important here. You know a definition for this from your GCSE studies. This is all about future generations. So give reasons why the use of the fibres from plants is sustainable, and we've got 2 marks, so 2 reasons. The first thing to say, okay, is that we can regrow plants. All right, so once we've used fibres from some plants, we can regrow them. We can't regrow fibres, okay? So it has to be plants. That's important. And the second thing to say is we've circled or underlined this sustainable idea. All right, so what is sustainable about? All right, well, really, sustainability is about being available for future generations. Okay. We could talk about this idea about it being renewable as well. That's kind of the same idea. Okay, so that's how we go about answering that question. Next up's a multiple choice. So we're going to do the tensile strength practical. All right, as soon as I see that, I'm thinking CPAC number 8. All right, and CPAC number 8, and I'm thinking here very quickly about the clamp stands, and then chucking my fibre in here, and here's one of my wonderful diagrams, and then hanging some weights off it. So that's immediately what comes into my head. Okay, so the tensile strength of plant fibres from different plants can be measured. Which of the following are variables that would need to be controlled when testing tensile strength? Now, if you look at this situation, all right, then you're going to look at what variables are going to do. Now, looking at that setup here, we know that pH isn't going to come into that because you're not going to have a pH in the air, all right? So that's not going to happen. So we can say that that one's not going on, all right? And then we think about some of these other ones. Now, temperature makes sense because we know that temperature has an effect on tensile strength and kind of vibration. So we're thinking now that that might be involved and that might be involved. And humidity is also involved, which doesn't necessarily help you. But light intensity. Okay, light intensity is all about leaves, really, and photosynthesis. And in this case, with the plant fibres, that's not going to have an effect on this. All right, so our answer here is C, which is temperature and humidity. Okay, now we go back to this diagram for this question. Describe how the tensile strength of these fibres can be measured. All right, so we know from our tensile strength practical that we did, that we've just done the other day, all right, that you got 2 clamp stands, you hang the fibre between them, and you're going to hang weights off them and see when it breaks, all right? But it's not quite that simple, because describe how the tensile strength of these things can be measured. So it's not talking about necessarily just how much weight it can take. We want to find out at the end of this practical what's the tensile strength of these fibres. And to work out the tensile strength, we've got to do a formula. All right. So we know, all right, that tensile strength is force divided by cross-sectional area. All right. So there's our first marking point, because we're trying to measure tensile strength. How are we going to measure cross-sectional area? All right, well, we're using plant fibres, so how are we going to calculate that? All right, we either need to do a calculation, all right, of how we work out cross-sectional area, or we might look at like use of a microscope or something about that. And then your other 2 marking points are going to be all about this situation here, and this is relatively straightforward, all right, which is the idea that we're going to add mass to that fibre or add force to that fibre, and we're going to wait to see how much it's going to break. Little technique here is you need to be talking about measurement, all right? We're not going to wait to see how it breaks, okay? We're going to measure how much mass that takes, okay? And last but not least, Now, last but not least, fibres of, can't pronounce that, jute and sisal, examined using an electron microscope. These electron micrographs were examined and the physical features of the fibres were measured. Okay, we've got 3 fibres. We've got 1, 2, 3 measurements. So analyse these data to evaluate the relationship between the structure of these plant fibres and their tensile strength. So we know we need to be talking about this, but we need to be talking about these as well. Now, common mistake here on this question, all right, is that you're going to try and find some sort of relationship between these two things. But that's not what the question's asking you. It's asking you to evaluate the relationship between the structure of these plant fibres, and the structure is all about the thickness and the lumen and the tensile strength. So take them as separate entities. So if I look at column 1, I can see very clearly, all right, that as the cell wall thickness increases, okay, the tensile strength increases. So positive correlation between cell wall thickness and mean tensile strength. Yeah? How do I know that? Okay, well, I can see that the Coral has the cell wall thickness which is highest, and it's got the highest mean tensile strength. So you talk about that, or you might say that the jute has got the least and it's got the least tensile strength. It's really important in our questions to put an example of how you've shown that. Okay, so that would be what you said there. Okay, and then because it's a 4-mark question and we've got an evaluating there, we need to talk about why that is. So why does the cell wall thickness, okay, why does the cell wall thickness mean more tensile strength? Well, it means that because we've got more lignin in there. Because the lignin is the thing which is directly going to contribute to the cell wall thickness. So more lignin, more tensile strength. Okay, there's our 3rd mark. But we do need to talk about this column as well. All right, but let's look at this column. All right, well, the higher the lumen, that's not necessarily related to tensile strength. Okay, the lower, no, not necessarily. It's a bit random, all right, because this one's got the highest diameter and the kind of the medium tensile strength. This one's got the smallest diameter but the highest tensile strength, and this one somewhere in between, but it's got the least. So we haven't got a correlation there. Don't be scared in a question to say that there is no correlation, okay, between variables. All right, happens. That is what scientists do. That's why they do experiments. Sometimes there is absolutely no correlation between those things, and that's an okay thing to say. All right, but as I said, the big mistake that people make in this question is they try and say something like, as the cell wall thickness increases and the diameter decreases, the mean tensile strength increases, or something like that, which is false. But we know by looking at these as separate entities that this has got a correlation, this hasn't. So separate that thing out. Hope that's helpful to you. I hope you're well, and I will speak to you again soon. Bye-bye.